In this video, we will try to solve problems on the topic HCF from the chapter Real Numbers. Okay. Actually, they are applications of HCF, word problems based on HCF. We will first analyze the question, and through question we will try to understand the concept. Okay. So first question. In a teacher's workshop, the number of teachers teaching French, Hindi and English are 48, 80 and 144 respectively. Find the minimum number of rooms required if in each room the same number of teachers are seated and all of them are of the same subject. Okay. Now, in question, it is given that there are three subject teachers. One is French, 48 teachers are there. Then Hindi, 80 teachers are there. And then English, 144 teachers are there. Okay. Now, they have given us three conditions which we need to satisfy. One condition is find the minimum number of rooms required. Okay, that is one condition. I put one here. Second condition is in each room the same number of teachers are to be seated. That is the second condition, same number of teachers. Okay. Now, third condition is all of them should be of the same subject. Okay, these three conditions are there. So I will try to solve this question part by part. Okay. Now, first condition, find the minimum number of rooms required. Then what I will do is I will put all those teachers in a single room. Okay. Then that is the minimum number of room which is required for accommodating all those teachers. Now, but when I look into the second condition, it says in each room the same number of teachers are to be seated. Yes, that is also not an issue when I am filling all the teachers in a single room. No problem. I haven't violated that second condition. But moving to the third condition, it says all the teachers should be of the same subject. Now there is a problem. Okay. What according to what I have done, in a single room I have filled all the teachers. So the teachers are mixed up now. But that is not allowed as per the question. So there should not be any mixing up of teachers. So then what I will do is to satisfy the third condition, I will take all those French teachers and take one room and fill that room with fully French teachers. So in one room I'll fill all the French teachers, 48 teachers, and in the second room I'll try to fill all the Hindi teachers, that is 80 Hindi teachers, and the third room I will fill with all the English teachers. Okay. So now this is the minimum number of rooms which is required. That is 3 rooms are required. So that there is no mixing up of teachers. Now, 2 conditions are satisfied, but the one condition which is actually the second condition which says that in each room same number of teachers are to be seated. But here that is not the case. In one room there are 48 teachers, second room 80 teachers, third room 144 teachers. So the numbers are different. Now, if now I understood that, what I have to do is I have to divide or distribute each teachers into different rooms in such a way that, for example, take the French teachers first. There are 48 French teachers. I can actually, out of those 48 teachers, I can take 2 teachers and using 24 rooms, I can fill all those 48 teachers. Now all the 24 rooms have got 2 French teachers each. Okay, that is a possibility. Or even I can go for a higher number. Say I can take say 4 teachers, 4 French teachers in each room, so that I need 12 rooms to fill 48 French teachers. Even I can go to a higher number, say 8. I can take 8 French teachers put 8 French teachers in a single room, so that I need 6 rooms for the French teachers. So what I understood is that the number of teachers which I can I should fill in a room must be a factor of 48. Otherwise, what happens? Suppose if I fill a room by 10 French teachers, what happens? In 4 rooms, I can fill 40 French teachers, where in each room 10 French teachers will be there. But in the 5th room, there are only 8 French teachers left. So the condition is not satisfied, which says that in all the room equal number of teachers should be there. So my point is that whatever be the number of teachers which I fill in a single room, it should be a factor of 48. Okay, should be a factor of 48. Similar is the case with Hindi teachers. Whatever be the number of teachers which I use to fill a single room, it must be a factor of 80. Okay. Similar the case with English teachers. The number of teachers which I use to fill a single room must be a factor of 144. Okay. Now, adding to that, I understand that the number of teachers in a French room must also be equal to the number of teachers in a Hindi room. In a Hindi room means a Hindi teaching teachers room. Similarly, that same number should be maintained in an English room also. So, the number of teachers which I should use to fill a room must not only be factors of individual numbers like 48, 80 and 144. They must be a common factor. They must be a common factor of these 3 numbers. Then only in each room there will be equal number of teachers. Okay. So my inference right now is that I have to find a common factor of these 3 numbers, 48, 80 and 144. Okay. But wait, for me to use the minimum number of rooms for all these teachers, a common factor is not enough actually. What I need is the highest common factor. Okay. Out of those common factors, I have to find out the highest common factor so that maximum number of teachers can be filled in a single room. Okay. Finally, I realized that this question, what it is actually asking is to find out the HCF of these 3 numbers, 48, 80 and 144. Then I know how to find the HCF. I have to use prime factorization and find out the HCF. So I'll just try to find out the HCF by prime factorization. 2, 24, 2, 12, 2, 6, 2, 3, 3, 1. Okay. So 48 I can write it as 48 equal to 2 raised to 4 into 3. Similarly, 80. 2, 40, 2, 20, 2, 10, 2, 5, 5, 1. So 80 I can write it as 2 raised to 4 into 5. And the last one, 144. 2, 72, 2, 36, 2, 18, 2, 9, 3, 3, 3, 1. So 144 I can write it as 2 raised to 4 into 3 square. Now what is HCF? HCF we know. HCF is the product of the smallest powers of each common prime factors involved. Product of smallest powers of each common prime factors involved. So in 48, 80 and 144, only one common prime factor is there, which is 2. 2 is present everywhere. And the smallest power of 2 in all the 3 cases, 2 has got the same power. So that will be the smallest power also. So HCF will be nothing but 2 raised to 4, which is equal to 16. Okay. So we find out that 16, the number of teachers in each room must be 16. Okay. Now, what are they asking? Actually, they are not asking that the number of teachers in each room which we need to fill. They are asking the minimum number of rooms required. Okay, minimum number of rooms required. So now, what we can do is, we know that 48 French teachers, we need 3 rooms. By filling 16 teachers in a single room, we need 3 rooms for French teachers alone. Similarly, for 80 Hindi teachers, we need how many rooms? By filling 16 teachers in a single room, we need 5 rooms. Okay, 80 by 60, 16, which is 5. Similarly, for English teachers, 144 by 16, that is nothing but 9. Okay. So now the total number of rooms required is 3 plus 5 plus 9. So that will be 8 plus 9, 17 rooms will be our answer. Final answer. 17 rooms will be our final answer. Be careful. If they are asking what should be the number of teachers that must be filled in each room, then HCF would be enough. Finding HCF would be enough. But here they have gone one step further. They are asking what should be the minimum number of rooms required. Then we have to calculate it like this way. Okay. Now we'll do one more question. Okay, this question. 3 sets of physics, chemistry and mathematics books have to be stacked in such a way that all the books are stored subject wise. Stacked means one book above the other. Okay. All the books are stored subject wise and the height of each stack is the same. The number of physics books is 144, the number of chemistry books is 180 and the number of mathematics books is 192. Assuming that the books are of same thickness, determine the number of stacks of physics, chemistry and mathematics books. Okay. This is also another application of HCF. We will try to solve this. This is similar to the question which we have seen earlier. I will tell you the 3 conditions. It is here. See, first condition, all the books are stored subject wise. Okay, that means there should not be any mixing up of the 3 textbooks. Okay, just like there shouldn't be any mixing up of teachers, subject teachers, which we have seen earlier. Same way, here you should not mix up the subject wise books. Then the second, that is the first condition. Okay, second condition, the height of each stack is the same. Just like the number of teachers in each room should be same, here they are saying the height of each stack is same. For this thing, they have also given that each book are of same thickness. Okay, we know that usually different textbooks like physics, chemistry and maths, if you take textbooks, usually they are of different thickness. But here they have said that all those textbooks, each one of them, they are of same thickness. Okay, so the second condition which says that height of each stack is same actually indicates that there should be equal number of books in each stack. Okay. Now the third condition which says that there should be minimum number of stacks, that condition is missing in this question. Maybe they have forgotten it or maybe they thought that that is not needed. That is not necessary to mention it. Okay. So what happens if it is not mentioned? If it is not mentioned, it is only required to find a common factor of these 3 numbers. Okay, there is no need to find the HCF. Which is the situation where we need to find the HCF is to get the minimum number of stacks required, to get the minimum number of rooms required. Then only we have to fill a maximum number of things into it, and then we have to find highest common factor. Okay, otherwise any common factor will be enough. Anyway, what they want us to do is HCF only. They have mentioned it or not, that is what they have. So we will do it accordingly. First we will write the data. We have got physics books. How many books are there? 144 physics books. Chemistry books are 180 and maths books are 192. We have to find HCF of these 3 numbers using time factorization. So 144, 72, 36, 18, 9, 3 3s are 9, 3 1s are 3. The next one, 180, 290, 245, 315, 35, 5, then 192, 296, 248, 224, 212, 26, 3, 3, 1. So 144 is equal to 2 raised to 4 into 3 square. 180 is equal to 2 square into 3 square into 5. 192 is equal to 2 square, 2 raised to, how many 2s are there? 1, 2, 3, 4, 5, 6. 2 raised to 6 into 3. Now HCF will be the product of smallest power of each common prime factors involved. So I can see that 2 and 3 are present everywhere in each of these 3 numbers. So I have to find the product of the smallest power of 2. What is the smallest power of 2? Square. This is the smallest power of 2 which is present in 180. So I have selected 2 square into, what is the smallest power of 3? Yes, it is present in 192, 3 raised to 1. Okay. So 2 square into 3, this is nothing but 4 into 3 which is equal to 12. So there should be 12 books in each stack. Okay, there should be 12 books in each stack. But what is their question? They are asking, determine the number of stacks of physics, chemistry and mathematics books. Okay, so they are not asking how many books are to be kept in each stack. They want number of stacks of physics books. So I'll write it here. Total 144 physics books are there. By stacking them, by taking 12 books in a stack, we need 12 stacks of physics books are required. Similarly, for 180 chemistry books, by making it stacks of 12 each, we need 180 by 12, which is equal to 15 stacks. Okay. Similarly, for 192 books of mathematics, we are keeping 12 books in a stack, so 192 by 12 will be 16. Yes, 16. 12 ones are 12. Yeah, 16 stacks are required. So these numbers will be our answer. 12 stacks of physics books, 15 stacks of chemistry and 16 stacks of maths books. Okay, hope it is clear.